My name is Dmitry. Welcome to the DP Labs channel. Today's episode will be about making a test stand for checking the characteristics of an electric motor. All right, shall we get started? Now we'll explain how it's built on the inside. This is a temporary structure. It doesn't have a foundation.
It's not a permanent structure.
It's not a permanent structure. Come on, we'll tell you about it. This is for Mikhail here for machine building and other stuff. Maria, come join us. Here it is, a foam sandwich panel. Here on this side, one of the 50s specifically taken from the city of Kovrov is present. Right now we're making shaped elements here.
Trim pieces.
Trim pieces. Everything is set on butyl sealant here. Come on, let's go. How much did we get here? 700 square meters?
If we're talking about the mono volume, then let me see. It's actually 24. Well, yeah, it ended up being 24 by 24.
Yeah, not bad, not bad. Let me think. Not bad, not bad.
About 570 square meters inside the mono volume, and in total, maybe around 780 or so, something like that, you know.
So, gentlemen, the foundation of our building is used shipping containers. 40-foot and 20-foot ones, right?
Yes. The gates, you could use the gates.
Yes, part of the container is actually used for storage purposes and maybe also for some office space, administrative areas, and so on, and we'll have a completely separate energy container as well. And the trusses, that's from some dismantled Soviet-era building, right?
The standard Soviet series.
And they have something to hang the overhead cranes on. We'll have 2 overhead cranes. The total span is just over 23 meters, so about 12 meters each. There is no foundation here. Everything just stands like this. The trusses are on floating pins. All of this can move around.
Hinged connections.
Yes, and everything here is made entirely of sandwich panels. 200 millimeters for the roof and 150 millimeters for the walls.
Yes. And we reinforced the containers. Notice that the trusses are unloaded onto the container nodes. Where the node didn't work out, we made U-shaped reinforcements outside and inside.
Right, so it wouldn't get crushed.
So it wouldn't get crushed, yes.
That's it. Shaped elements, all sorts of decorative trims and so on. We bought this very strip specifically for this project, and we have a sharp knife and a manual bender, both ready to use. Just like this one. We bend the shaped elements ourselves. And as you know, it's in a protective film, right?
Yes.
It turns out looking solid, many shaped elements here. No need to pay much, we do it ourselves. It's 0.4, right?
Yes.
The trims, did you see where the corners just aren't covered?
The junction to the wall.
They made the ridge cap here. By the way, is the ridge cap foamed?
Yes. Well, that's it. We did everything ourselves.
That's it, great. And the main thing is, this is our know-how. Mikhail and I came up with it. The back wall is just heavy-duty shelving. We bought them used from somewhere. They're securely fastened to the floor, and they actually serve as the primary structural wall frame.
Pipes are attached to them with spacers, and the sandwich panels are mounted onto those pipes. Then
that's how it turned out. By the way, are we going to have those wind braces here as well, or
not? No, for now we've decided to leave just one, yeah? It's a shame about the span.
Maybe we could unscrew it, or
not? No, we'll leave it. It's not in the way.
Mikhail and Vasily.
Yeah, the ideologist. There was no architect. And
Diamond did the drawings right here, yeah.
We figured out we wanted then.
It just took off from there. Yeah, because Dima Klimkin was here too, and Makarich. It was a joint creative effort. We think we'll do this again. Since the building isn't permanent, you can put it up without a construction permit, since you can move it if needed. And when you have to cover a large volume, using sandwich panels isn't cheap. Here, the sandwich panels alone cost 4 million, right?
A little less.
Yeah, but we have almost 600 square meters of space, including the interiors of the containers. That's actually a lot. And the height is good. You can even set up crane beams. Look, it's hard to solve problems. Yeah. On a table made of foam plastic, yeah. This is Oleg, the construction manager. These are professionals like the experienced road builders we saw recently working on the new project. I like the foam plastic table because it is lightweight and convenient. Which ones do you mean, and about what exactly are you asking? Well, the ones in Bugara, in drunken Bugara. Oh, we're walking here, and there's something funny. So we're driving, by that round building where they sell all sorts of stuff. And there are 2 houses with Tehran written on them. So it's 11 in the morning, we're coming back from the gym, and they're just totally wasted. One is holding up the other, and they're walking like construction workers. On his stance,
Like a little house, right? Yeah.
here we have people working with bright, burning eyes. Yes, here we have a regime of sobriety and correction. Some people got caught during correction, what can I say? But you know, yeah, we'll cut this part out. Let's take a look at this. And this is...
Standard elements.
Oh, look at that. They're finally using the printer. I bought a printer just for this.
That's exactly what they're bending right now.
Well, everything is great to mix concrete.
Add more. Small pieces, well, these need to be removed. Right here, such places.
Are you going to bend something now?
No, they are so wild. There were many here. We will most likely install heavy equipment and remove some of the slabs.
And make a separate foundation for them.
But there is no point in cutting the expensive flooring yet. One man speaks.
Right here, we're going to have interesting gates, like on an Icarus bus, semi-sliding.
Yeah, like the front doors on an Icarus. They'll slide open and move to the side, one half and the other half.
Yes, by the way, we were really lucky to get this whole structure. Almost 1.5 times the price of scrap metal, right, Vayash? Or maybe even twice as much.
1,000. You paid slightly less than 1,000 rubles per square meter for the metal structure, approximately.
Yeah, they were a bit rusty, but the metal is so thick we sandblasted them. And is this epoxy or polyurethane? Polyurethane. You even painted them in winter, right? We painted them in winter, and they're just fine. The paint is amazing. Yeah, we'll just touch up a few spots here and there, and that's it. Yeah, and that's all. I think it'll last, honestly, even for our grandchildren.
It definitely will, most certainly.
I think we really invested heavily here.
Well, they were already there. We extended the posts. We have a joint between the posts. Our building is taller than the one we bought from.
Yeah, and longer too, since there are also those beams made over there. Well, I like it, don't you? What do you think? Does it look nice? We like it. Yeah, well, the main thing is that someone... Yeah.
We calculated the beams for a snow load of 280 kilograms per square meter.
Yeah, well, it'll slide off just fine here. Maybe even, well, we probably won't install any snow guards.
So do it. Vasily doesn't want to cut corners. It scares him.
So, gentlemen, I think in a couple of months it'll be ready. We'll start finishing up the interior here, settling in and all that. By the way, I want to mention our grasshopper is still alive, a beast of a machine. There's nothing left of the electronics on the
contactors,
on the buttons. It runs, it drives. It's a good thing. We got it cheap. 400.
We bought it for 400.
Yeah, otherwise it's more or less in good shape. Someday we'll get around to it. And also, Ma Maria, move over there, but that's for the next video. Spoiler alert, there's another building. Basically, we're expanding. Yeah, we're off, going to hustle, spin things up, and so on.
To win.
To win, that's it. Basically, we were born to win. Let's go.
To work.
Yeah, that's it, let's work.
The sun's up high?
Yeah, the sun's still high. And anyway, on sewing night, work really doesn't actually get in the way. Yeah. So here's our dynamometric test stand. Now Mikhail will talk about the main idea, what it's made of, and how it works. It's entirely his creation.
The dynamometric stand, the concrete casting inside which 2 separate oil tanks are embedded. Basically, it's symmetrical. These are the fill and drain necks of these tanks. We're planning to use oil. What's the point and the feature of this stand? The fact that on top we'll install the test engine. Its test housing is at the bottom. Well, it's closed right now because there's painting work going on here. It will be installed on top, and we won't need to manufacture a separate housing for this purpose. On the test stand itself, there will be a specially designed front bearing hub that is suitable for any engine operating at speeds of up to 12,000 RPM. On the top, in this specific spot, a tailstock will be carefully glued and precisely aligned, which will securely hold the upper bearing of the test engine in place. And through a bunch of hoses will be carefully threaded through here, and we'll show it, and I'll show you from that side as well. We'll be pouring cooled liquid over the motor windings, both from above and below, to ensure proper cooling. We're ready to supply up to 90 liters per minute to both the upper and lower motors. That is, it's actually more than you would find in any regular vehicle. So
That is, Mikhail will be able to evaluate both types of coreless motors, just to check our theories, and also ready-made motors with housings as well. The main thing is that this setup will be very rigid, there won't be any vibrations, and we'll be able to take accurate measurements of the parameters.
yes, our system is certainly designed to be vibration resistant, even in challenging environments. For temperature measurement, each of our motors has a main heat exchanger, which is the motor's heat exchanger, and a slightly smaller heat exchanger for the test stand's controller. And there are 6 servo valves installed. This one controls this heat exchanger and the temperature that will be supplied to the motor and the controller. And this servo valve controls the flow of liquid through the controller. For example, if we have a task where a small pump will be installed on the equipment, we need to see how much the motor will heat up, or the controller. We can specify that the motor will be tested at a temperature of 50 degrees. Specifically, the unit under test. There is a heating element installed. We heat the liquid and maintain a temperature of 50 degrees throughout the entire test cycle. And accordingly, we can remove or extract, according to calculations, approximately up to 90 kilowatts of heat energy with a 50-degree temperature difference. That is, our motor could actually be boiling hot, but we absolutely won't let it burn out. Even a high-power motor, even one with relatively low efficiency, can still be tested there without any issues.
And well, we'll be able to reach up to about 12,000 revolutions per minute.
Yes, the calculation is that we can reduce the hub of the bearing separately if needed. Why not? It can be machined into a different hub with a different bearing. But right now, the bearing is quite large so that it can transmit the torque to the lower test stand. And
What would we use, do you think, as the load motor?
a reliable motor from a Lexus GS 450 for your needs.
And how are we going to handle the recuperation of the generated energy?
Yes, we will return the energy back to the test stand itself. If we have too much excess energy, if the voltage is too high, we have a water drain, and there will be 2 powerful heating elements installed on this and that side where we will dump all the surplus energy. Because if the lower motor starts generating, there will be too much voltage. For example, it's 400, but we're testing a 90-volt motor.
Well, so everything will be fine. The main thing is high rigidity. With the tailstock, everything will be easy.
Yes, any height.
So where are we going to get it?
No, we'll make our own completely. There will be a bearing. We thought about using a tailstock from a lathe, but structurally it's inconvenient here. We'll have a not-so-thick, approximately 8-centimeter disc with a mounted hub and a supporting bearing. Yes.
So what kind of concrete do we have here?
The concrete, what we tried is, we aimed for B60, but we ended up with B70. It's self-compacting concrete. Inside here, we still have a little bit of space left where we haven't glued anything in place just yet. A piece of concrete will be glued in here where spots will be ground out for a standard ball guide, which is exactly what the upper headstock will ride on. Here, accordingly, there's also a drain into the motor's tank. That motor is cooled separately. And what's over there? Can this be lifted? Yes, it can. Let's show ours. Sign the main hole.
And right now it's empty in there. The drum hole. By the way, we cut the formwork for all this on a CO2 laser and assembled it like that. A scary contraption.
I can take this one out too. And
What's this?
this is the top cover of the motor, actually, from the Exus.
Basically, there's a shortage of ready-made test benches. Yeah, there just isn't exactly what we need. Remember, Misha, we saw that someone from BMW was offering some money? Yeah.
From BMW for 170,000 euros, old one.
First shame it.
I won't open it. You need pins for that.
That's exactly why you have these instructions.
An opener. Say,
We'll open it after we reach 10,000 subscribers. Seriously. Or for 600,000 likes.
I think they made it so that we can't open it without special release bolts. It's sitting really tight in its seat because this is the first bearing of the engine. Next.
Time then.
This is our complete test stand control board, which will monitor the temperature using temperature sensors. It will also control the pumps, the lower motor, and the upper motor. And it has several universal oil interfaces for third-party controllers in case we ever need to test something like that. This design provides us with additional flexibility.
Yes, I was the one who developed the board, not him. You know who our main person is for inverters and all that. It's him, that's his area of expertise. So, Mikhail, the main question is, when will this finally start working?
I think we'll have trial runs in about a month or so. A lot of things still need to arrive for the transformer, and the electrical cabinets themselves are complicated. Right now, we're assembling and putting everything together.
Well, that's great. Soon we'll finally have a test stand, and at last we'll have the next part of the Dyno motor series, part 2. I bought the motor that I was told is the right one. The real Slavyanka, not the Armenian one. And finally, we'll be able to test it so there are no more questions. So will we be able to do a calibration test as well? At least put in a standard AIR motor and run it through? In
any motor. Overall, our setup is designed for motors up to 400 millimeters in diameter and up to 400 millimeters in height. We can physically test a motor like that. Larger motors can also be installed here.
But then we'll have to get creative. So why was this test bench built? Since we decided to make our own power motors, and you just can't do without a test bench for power units. Testing everything with makeshift setups just isn't good. And most importantly, we'll be able to test in real operating modes like S1 and so on.
Any modes? Yes, because we have a highly effective and powerful cooling system. We can simply set any temperature conditions we want.
We can even push it to overload mode and really put it through its paces. In short, the test bench is absolutely essential.
It's really convenient that we won't have to machine, cast, or manufacture a new motor housing every time. We wind the core, install it. If we don't like it, we just cut off the windings. Everything will be much faster and simpler for us.
And most importantly, the alignment will be excellent. No vibrations, nothing at all. Everything will be rigid and precise.
That we guarantee.
This is the first step towards concrete beds for machines,
so to speak. Yes, it was important to practice on something. The CO2 laser helps, but it still introduces its own nuances.
So the formwork was cut on it. Do we still have it here or not?
Well, it's already come apart here.
All right, Mikhail, let's see what else is actually new in our so-called circus tent today.
Well, we finished the major overhaul of the FD11 machine in terms of geometry. Now it's going to be carefully painted, then fully assembled, and finally accepted by us according to the strict GOST standards. We'll accept it ourselves according to GOST.
And is this the one you bought here?
Yes, the one. Yes.
There was a machine for sale in the neighboring village.
We're finishing up the painting work. All the other geometry was checked and done. It officially met the V grade according to GOST.
In terms of precision?
In terms of precision, yes. There are NPV and A grades. It qualified as high precision.
And how much is that? What does that mean?
Well, for collective farms, machines with the letter N. At regular industrial enterprises, it's the letter P. And in tool shops and for precision work, it's V. And the letter A is close to master machines in the Soviet Union. I know of 5 models that were made.
I see. And we're priming, right?
This is putty, and then we'll prime it.
Which one? Green?
No, it'll be a bit lighter than this color.
Because you have that color?
No, because that's how the Heckerts painted it. I really like the Heckert color. On it, oily grime and the like aren't visible for years.
I see. Just out of curiosity, could you tell me how much time did it take? And what was overhauled?
Overhauled? Well, everything. The carriage was scraped in. I can show you this spot right here. The carriage, the mating part, the compound slide, its mating part, the wedges were scraped in. The entire carriage itself was scraped. The tailstock, the headstock, the bed, only the bed. It was poorly ground. It was ground, but it was done poorly, not with much care. For a week, they bent the machine on supports to get about 12 microns for the entire measurement program. Not for the carriage stroke, but for the entire stroke.
How so?
They bent it with supports.
And he kind of arched, so will it stay like that?
Yes, it will remain so. But until we unscrew it...
Oh, well, because he's standing here?
Yes. It's in the zeros, maybe? He's in the zeros, yes.
Yeah.
Because when they say that precision machines can stand on vibration mounts, this is not true. Without normal maple supports and without an anchoring system, the machine can never be physically level.
Yeah. That's how it is.
Turning. There are other machines that can do this, but a lathe cannot. Well,
so how is it to you? Worn out, not too worn out?
It was thoroughly overhauled, but during the process of the overhaul, they somehow completely missed checking the angle of the carriage prism, off by several degrees, which was a significant oversight. Because of that, the machine lacked rigidity and nobody worked on it. That's why we got it like this, probably why they got rid of it. It was literally shaking when it arrived.
Well, I see. But how much did we get it for?
We took him for 2 prices. No more expensive. We took 120,000 from him.
Yeah. Well, in short, right here, thanks to those who sold. I don't know, there's some guy from Lobanov here. They took it from Lobanov, right?
A little further than Lobanov. Yudin? Yudin, well, something like that.
Got it. Listen, and the engine, we have a frequency converter.
It was with an ACS, but since we have a frequency converter, we'll switch it to run on the frequency converter without the ACS. An FT11, we can shoot a video later if anyone's interested. This is one of the most unusual machines on the planet. It doesn't have a vertical prism like everyone else does. Instead, it has an inverted prism. Its prism is quite heavy and sticks downward, pointing toward the ground. And it's like this. Here it is. This is the prism I'm referring to. And on all the other machines, as you can see, the prism is positioned vertically. And what does that do? This allowed them, since it has guards here, to hide them inside. Such an inverted prism is used on grinding machines. Then,
so that the abrasive doesn't spill out?
The abrasive doesn't spill out, it's more rigid.
So we can achieve more or less high precision on it.
Right. Yes, it has auto feed and a short longitudinal stroke. And can we
put modern attachments on it?
Modern ones.
Or maybe you'll attach them later on?
We'll practice on this one.
Aha, got it. And we made and installed a tailstock, right?
Yes, it came without a tailstock too. We bought one and installed it. We ended up with about 0.015 millimeters misalignment, but we didn't do a full overhaul of the tailstock.
Where did you get it from? On
Avito.
Ah. Just like that. Gentlemen, by the way, if you're interested in machine repair, maybe we can ask Misha. I even gave him a stabilizer so he can film the process and show how the work is done. But I can't come here that often myself. If you're interested, we can film it, sure. If you're interested, leave a like. Yes.
Absolutely. If there are a lot of likes, we'll film it. Why and how we scrape, how to scrape by the reflection on white paint, on red paint.
Is white different from white paint?
Drastically.
My God, this is some kind of shamanism already.
Shamanism. First you have to do it on one paint, then on the other. I'll explain why you need to switch from one to the other.
Wow. All right, maybe we'll talk about scraping. But tell them about this, our idea, our concept. What is this?
This is a Bulgarian machining center. CM040, as far as I know, I think.
This is its frame?
The frame, yes, the structure itself. I got it probably about 14 years ago. I carried it around with me. I always wanted to try making it first out of polymer concrete, but now I realize it should be made from regular concrete. And now, based on its design, we're going to try to make our own version. But since the original uses sliding ways and ours will use linear rails, it's going to change quite a bit. And we want to make it so that the fourth axis is a rotary table. The horizontal one, here it is, it originally used a hearth coupling with 5-degree increments.
Degrees, a unit of measurement.
Well, it was rigid, mainly for that purpose, but we want to make a direct drive, fully rotary version.
Yeah, exactly, that's the idea, so we don't have to worry about it at all. We tried it, you said we need an encoder.
An encoder, yes. Right now we're looking for a high-quality encoder that provides at least 21 bits, and preferably 24, with a large diameter. There are some important nuances. We tested our controllers, no issues at all, using an automotive resolver. They provide an accuracy of about 40 arc seconds. That's about 3 to 4 times worse than what Soviet machining centers used to deliver. It's just that with those, this information is easy to obtain. But everyone writes we have 0.001 degrees. They also claim 0.001 degrees, but at the same time say that in reality what they have is a positioning accuracy of 20 arc seconds.
And how much do we need?
Well, if we can hit 20 arc seconds, that would be awesome.
Ah, so that would be enough for...
For any general industrial task, that's more than enough. That's less than 1/100 of a millimeter over a 400 millimeter diameter. Yeah. Well, discreetly. Accordingly, the closer to the center, the more precise it is.
So basically, we don't have any issues with control. The main thing is to have the position sensor itself.
Yes.
And we can rotate it, right?
We can rotate it, yes. We can hit the rotation. The question is really about accuracy, how to achieve higher accuracy.
You mentioned that maybe we could get a Chinese encoder.
We requested it, yes. They just take a really long time to respond. Apparently, it's a very unusual request.
Yeah. Also, gentlemen, we have... Misha and I were saving the SM1 machine back then, right? I think you'll see it again someday.
Yes, the 5-axis one that made a single part. The first one was made by the Savilovsky machine building plant.
Yes, Misha and I were there when the plant was already dying. That's where Misha actually got that beautiful globe table for 50,000 rubles, you know?
Before the tooling. It's a 5-axis machine, and without that table, it has a double swivel head, which was before the tooling.
It had it? Yeah, right. Take a picture of Masha. That nameplate over there is from it.
Well, it would have been a sin not to buy this for 50,000 rubles, right? I'm curious, what control system does it have? Oh no, this table doesn't have its own control system. So it just connects directly, right? Yeah, here are its outputs. And it's basically brand new. It's factory packed. And this was made here, right? Yeah, Saviol made it themselves. I wonder, did they copy it from someone or is it their own design? Can't say for sure. So it moves in 2 axes like this, and it's a tilt rotary table that tilts and rotates, but the table doesn't clamp down. It's pretty powerful. Yeah, this is a serious piece of equipment. It comes in a 400 version. You can't lift it by yourself. Oh, and what's this here? This is actually the bed of the STM 100 machine, specifically this upper part right here. And what kind of machine is that exactly? Could you please tell me more about it? It's a turning milling machine from Saviolovsky. We'll show it a bit later in the summer. We'll show it. So we're installing our boring machine. It's a bit dark over there, the lighting. Yeah, today's video is just full of spoilers. Team 1, this is the boring machine, right? Yes, it's a horizontal boring machine. I can turn on the light. Well, it's okay, nothing serious can be seen anyway. We're setting up the supports, getting ready for pouring. We made the studs from 30 kilograms from the garden. No, we actually bought these studs. They're for frames, used to tighten car frames. That's it, slipped my mind. All right, here are the studs. U-bolts, specifically from a Maz truck. They're forged, different widths, split in half, and they reach all the way to the bottom of our molds. Yeah, you understood? Here the foundation was made separately, properly? Yes, just in case it needed to be moved, a separate foundation. Oh, really? Was it possible to do it with the foundation? No, we probably won't take it here, but we'll take 12 tons separately, one at a time. We bought a separate one. Yes, fully operational with a universal double swivel milling head. If I take a moment to clean up the mess, I can even open it up for you if you'd like. The universal head, it rotates in this direction, and then it rotates. That's how its spindle rotates. The table travel is 1,240 by 1,240. And we can put 3 tons on the table. Where did you get it from? I bought it. This is the last machine that left the Zeal factory in working condition, not as scrap metal. From which factory? Zeal. Oh, Zeal. Lukachov, yes. Cool. So it'll keep working for a while. So, Mikhail, what do we have here? This is the main power transformer, the main primary power transformer for our test stand. We had a 160 kilowatt uninterruptible power supply, or UPS, that unfortunately burned out. After that happened, we took the transformer from this unit and carefully wound our own custom winding on it. And as a result, we wound it in such a way as to get what is known as an 18-pulse rectifier, which is quite significant in this context. Now, if we look closely, we have 1, 2, 3 sets of diode bridges. And why do we wind something so unusual, you might ask? It's to get the voltage ripple of the rectified output after our adjustments ended up being just 1 or 2 volts, that is plus or minus 0.6 volts at 95 volts rectified. Accordingly, we can multiply 95 volts by 3 in order to get a rectified voltage of about 200 volts, but in reality we actually need 400 volts. Therefore, we'll make 400 volts with 24.
Yeah, and we'll actually be winding the tape later.
The tape? It was wound with aluminum tape, and we ordered an insulator because this one was damaged. Yeah, a specific Captain one. And yes, we'll use some of this tape and buy our own 0.5 millimeter tape, because that will be 2 layers of 0.4, and the 0.5, some of the windings will be 2 layers of 0.5.
Do we need a capacitor? Wait a sec.
We have capacitors, inductors, kind of. Basically, we're taking everything, because we're aiming for the ripple to be around 0.5%, at most 1% total. So the test bench should work almost like it's running off a battery.
Right.
And accordingly, it definitely won't sag under heavy loads.
Yeah, and we'll also have it working with recovery too. We'll actually be able to run high power in principle.
Yes, without putting a load on the transformer. And this is a real transformer, not an auto transformer. So we're isolated from the mains.
Yeah, that will be for safety. For those who don't get it, for you to get shocked, you'd have to grab both transformer outputs. If you grab just one, nothing will happen.
Yeah.
There you go. Transformer is awesome.
Oops, is this choke also from the UPS?
Yes, this is a three-phase choke. It's from the UPS, and there's also another output transformer. I don't know if we'll keep it or not. Maybe. And this is just a choke.
Are we going to use it?
Yes, indeed.
Hey,
Well, we'll smooth it out, so to speak, even better.
here. That's how it is, gentlemen. Almost battery powered. Very convenient. Maybe we should do long-term testing, like running all sorts of resource tests on a test bench.
Yes, and we also want, if the windings are connected in series, to have the option to test low voltage controllers as well, as needed. Or there will be a separate transformer. Also, it's hard to divide 400
Yeah, well, in the worst case,
to 90 and get a more or less whole number.
in the worst case, when it's low voltage, low power motors, we'll put a variac outside and lower it.
Or we'll rewind this transformer. Or this one, yes, the auto transformer, it has all these outputs on it. Like, no, it's not a car, there's a car there. It's also completely isolating. This is from a machining center that sawed up scrap metal.
Hey. Good, it will come in handy, household. Here. So. Well, what's the conclusion? Well then, gentlemen, I hope you enjoyed it. There will be a lot of likes. Mikhail promised he would film how he repairs machines. Little by little, we're restoring and building up our own machine park, as you saw, and constructing a building. Everything is moving forward for us. Well then, subscribe to the channel, share your likes. All the best. Bye.